Now let me introduce our speaker, Dr. Mohammad Farukh Hashmi, sorry, a senior member IEEE, received the BE degree in ECE from Bhopal University in 2007 and ME in Digital Techniques and Instrumentation from Sri Govindaram Srikari Institute of Technology and Science, Bhopal University, in the year 2010, and PhD degree from VNIT Nagpur in 2015 under the supervision of Dr. Avinash G. Keskar. He is currently working as an assistant professor with the Department of ECE, NIT Warangal. He has published up to 100 articles, including 45 SCI indexed and in other reputed journals like IEEE, elsewhere, and Springer. He has also published 3 patents, and he was a PI of one research project of worth 5 lakhs funded by the Institute Seed Grant through TechUp 3. He has teaching and research experience of 13 years. He has supervised 2 PhD scholars. He is currently guiding 4 PhD scholars. His current research interest includes computer vision, machine learning, deep learning, IoT, etc. There are a lot of lists. He has reviewed more than 300 plus articles under Web of Science. He also served as an active and potential technical reviewer for IEEE Access, IET Image Processing, and other reputed journals. And he is a senior member of IEEE, fellow member of IATE, and a life member of IE, a life member of ISTE, and life member of IAENG Society. We welcome you, sir.
Thank you. Thank you, Anil. Good morning, Anil. So today I am going to deliver a talk on deep learning for medical imaging analysis and application. So medical imaging is one of the challenging area with us nowadays because we are working towards the healthcare, improvement in healthcare with the help of AI. And in the umbrella of AI, as we have seen, machine learning is one of the part. In machine learning, deep learning is one of the subset of machine learning. Okay. So in my first session, I would like to give a talk on what are the modalities are available and how we can solve the problems related to various medical imaging applications. Okay, so various medical. So we can see in the figure we have CT scan, we have MRI, okay, and how we can take the data from the brain through EEG like electroencephalogram. So these are the modalities are available in terms of medical instrumentation, and with the help of various medical instruments, we are collecting the data. So today we can say today is the era of data science. So every day our data are increasing day by day. Okay, if we talk about data science, why we want AI? Because we need to handle the huge amount of the data. We can say big data. Okay, and in that case, as per our theme of the FDP, image fusion. That means we can say how we are going to apply the fusion techniques to improve the visual quality. Okay, and visual quality is mandatory to get the actual decision. Okay, so in that case, if you see if you are having the any sonography or in the sonography imaging, what exactly problem would be there? What are the objects we are going to analyze or visually analyze? It would be a one suspect. That means whatever the technician would be there, he cannot take the decision. A practitioner cannot take a decision, or expert need to be applied to take the decision on the basis of various decision making quality. So we can increase the visual quality and visual perception quality in terms of our accuracy or in terms of various performance parameters. Okay, we'll see one by one. So deep learning, the part of deep learning I would like to cover in our next session, because next session will have the practically how we can utilize the deep learning towards the various computer vision or towards the various image processing or various imaging application. So in my talk, I will discuss about today medical imaging, one of the area as we are going to cover, as well as we see deep learning, how deep learning would be helpful in medical image analysis. That means when we are going to analyze the medical image, how deep learning will help, as well as what are the applications are available, and we'll see various work done. That means we have implemented various work in this domain with the help of our research students, with the help of our graduate or master students. We'll see that one, how we have implemented all this method using various machine learning based method, using various deep learning based method. So related to brain tumor detection, related to lung disease prediction towards the COVID-19, lung obesity or viral pneumonia. So I will discuss one of my highly cited research work in terms of pneumonia detection and classification also. The time will permit, as well as breast cancer or mammogram images detection using various machine learning based algorithm. So first of all, we need to know what is the need for this study. That means as we can say nowadays everybody is talking. So we can say healthcare is one of the challenging area with us. And in this area, we see there are many problems are available. That means various modalities are going to become advanced and more advanced. The previously we'll see about X-ray imaging. So see the previously the X-ray imaging was like it was the only one geometry or one projection was there. Now X-ray imaging is the 360-degree projection would be there. That means the person entire body can be X-ray and we can collect the whatever the part has fractured or whatever the part is completely okay. That would be very easy thing we have recovered. So how instrumentation, how medical imaging has helped, and what are the other challenges with us, like previously when we were taking MRI imaging or any other CT scan imaging, it was taking time to that means implement or provide the final result. And that means at the time the expert also was very important. Nowadays that AI itself will be helpful to decide what is the problem is there in the that particular CT scan or particular kind of MRI images. That means decision making will take place immediately once report will produce by the system. And the processing time and producing time of the report has decreased. Why? So because AI ML is strongly applied and we can get the result very fast. That is the major advantage we receive. So the study of medical imaging is concerned with our interaction with all forms of radiation, and also one more major part, how much this radiation what we are using. That means we are using electromagnetic field to generate the all, that means this CT scan or MRI and all. So how it will be more helpful for the, that means patient, or it will not give the any problem to the patient. So that is the major challenge with us. So interaction of all forms of radiation and with their impact, with their effect to the that kind of disease will be helpful or will be reduced or not. So like cancer is one of the difficult issue was there 10 years ago, 15 years ago. Nowadays it has been resolved by the early stage detection. Okay, so that is the major case, how it would be helpful. So development of various appropriate technology to extract the clinically useful information and in the form of image or whatever the image we have observed. Another challenges with us in terms of medical imaging, the technique and process for creating visual representation. As I said, visual representation is interior body for clinical analysis, as we have seen, and medical intervention as well as visual representation of function of some organ or tissue. Earlier days, it was very difficult to analyze the complete body part, complete scanning part. These all are the studies we have received now because of medical imaging. If you see, so we are an engineer, how we can help towards the medical imaging, because medically, whatever the biomedical imaging, if you see the concern with the doctor, we cannot take any decision. Okay, decision making will be taken care by only doctor, not by us. So because they know more than us, only our concern is what we have the data. How this data can be analyzed And in this data, what are the problems are there? Suppose in the cancer also there is a possibility that cancerous area may be cancerous or may not be cancerous. So that means we need to know benign or malignant. These two conditions are there in cancer. So definitely there is a dilemma would be there. Suppose if we have read the report of sonography. Okay, some kidney stone problem is there. Kidney stone is one of the area in medical imaging still very challenging. Why? Because multiple stones are available and multiple parts are available in the our stomach. So in that case, what are the reports they are generating? They are saying this is suspected. Okay, 2 millimeter size of the stone would be there, suspected. They are not compulsory confirming because the report has been generated by technician, not by doctor. Okay, they know only what are the procedure will be there. They are applying the procedure and finally they are producing the report with the system and computer. Finally, and they are writing the whatever the comment would be there now, comments will confirm by the doctor because doctor knows each and everything according to that report and he will say, okay, this problem will be like one of the example in Parkinson disease. So Parkinson disease, the deviation in the human motion, that human will have the infected by Parkinson disease. That means EEG signal will be collected. So how EEG will be collected? That means some brain will have some nerve, that nerve will have the problem due to the person will affect that Parkinson disease. Under that, CT scan will be taken or MRI will be taken. Now all this will be given to the doctor and doctor will confirm what is the condition of CT scan or nerve would be there. Only report cannot be understand by you. Even if you are a medical practitioner, you can do. But if you are not medical practitioner, you cannot do. That means it's a huge gap between us and this medical imaging. That means you are a researcher in medical imaging, so definitely you can work according to your requirement. Like that, we are working, medical images are there, the ground truths are there, and we are implementing algorithm. We are finding whether that area will be cancerous or not. So these are all cases we need to consider when we are working in medical imaging. Okay, so in medical images, basically medical images are required for diagnosis purpose. Diagnosis is one of the requirement. So ultimately, consultation information obtained from the patient and physical examination like inspection or measurement or medical tests are available. So laboratory tests or biosignal analysis or image analysis. So our concern would be image analysis. We will not go for signal processing. Signal processing is also one of the area biomedical signal processing related to one dimensional signal. But we are going to talk towards our requirement images. So we'll see image analysis. So why imaging are important? So imaging are related to imaging sensors. So according to that, we'll see to diagnose, to treat, and cure the patient without causing any harmful side effect. As I said, because EMF we are using, but it will not be side effect. Okay. So there is some radiation we are using. Some irritation will take place while taking off CT scan or like that. But diagnosis will not be harmful for that. Ultimately, computer vision will be very helpful here because texture, shape, or contour or prior knowledge along with the contextual information is image sequence. It will provide 3D or 4D information. As I said, in terms of brain, we want 3D information. We want projection of the brain. We want slices of the brain. What CT scan will do will provide the slices because our brain having the multiple area. And that area will give this area, the complete skull will be opened and will be just displayed or visualized by the medical unit. So in terms of to handle it, to see the inside patient without having to cut them and open. That means we should not require to insert anything. We just need to open. Right. This is the form. So for the final objective, our benefit without you can do like that. Okay. So as we have seen, our final objective is to benefit the patients without aiding already high medical cost. That means you not required to high medical cost as per the requirement. So these are the modalities are available. We have seen X-ray, we know computer tomography, we know medical resonance imaging, MRI, we know single photon imaging computer tomography, we know positron imaging tomography, we know ultrasound or nuclear magnetic resonance and magnetic resonance angiogram. So these are the imaging we are using and all tests are available in hospitals depend on the condition. Like you will see, suppose someone having the problem in back, whatever the back bones are there, that cannot be recovered by X-ray. So what we need to apply? We need to apply MRI. So in MRI there is a disc, some disc would be there in back. So that can be analyzed through MRI only. So some tests are definitely will be costly, but it will be definitely required. Like nuclear imaging we are using. Sometimes we are unable to analyze the complete brain. So that is also more important. That's why I said these are the modalities are available. We can see CT scan would be like that, MRI would be like that, nuclear also would be like that, like positron imaging we are using and ultrasound. So these are the images. We can just recover the images in terms of this way. So these are the instruments we are using, and by these instruments we are able to extract. These are the images would be there. These are the images would be there. This is the X-ray vision. This is the sound wave, or this is the ultrasound. Okay. So all this kind of modality we can say in terms of example, CT scan produces up to 2000 images within the 25 seconds. And PET and computer tomography requires review of up to 6,000 images. And this breast ultrasound can create 5,000 images. So this you can say these are the instruments are available in the hospital as we are using. That is the completely available with respect to biomedical instrumentation. But our concern is how to handle these images, how to solve the problem of these images, how this image report will be generated. That is by the program, by the code. Our concern as an engineer, we have to provide this solution only. Okay. Other parts are not our concern because we are not expertise in that level and we should not touch also to that. And also every research should be taken care by the expert support only. Without expert support, this research will not be successful. That's the reason if you heard about the clinical research, as I said, clinical research is one of the area that we are not doing, healthcare people are doing. What they are doing, every medicines are coming in the market. Without clinical trial, the medicine will not be available in the market. Okay, so there are many research are going on and every clinical trial will take place around 10 to 15 years. That medicine will reach to the market. Trial 1, trial 2 stages are there. And all MNCs, all industries are working to produce the report and with the help of discussion of whatever the patient, that means what patients has faced the problem. And that means opinion of the patient will be given to the doctor and doctor will write the report and that report will be given to the company. Then company will analyze what are the impact has happened or side effect happened, adverse event happened. After that, that medicine will be available in the market. So due to clinician condition, we cannot do. Our concern is we cannot touch so these images will be generated under the condition or under the observation of complete expert people. That means whatever the images are available in our library or whatever the Kaggle software or somewhere in the mobile. So what you are using, that images, suppose you are using your own image. You have taken image, you cannot use without the expert because that image you don't know. Whatever the ground truth part will be there, whatever the actual label part would be there, that is the major requirement. So images must be available with the label data. Okay, that is the machine learning requirement. So we talk here samples of CT scan images are in terms of sample of MRI images, sample of ultrasound images, sample of X-ray images. So this is the X-ray images are there. Like if you have seen dental people also taking the X-ray. Without X-ray, they cannot identify root canal in every process. That same process, this is the hand fracture or anything will happen, it will be analyzed by the X-ray itself only. And pneumonia is one of the area. Pneumonia classification, the pneumonia having many classes, like COVID-19 also comes under the pneumonia only. So initially when COVID-19 was there, they diagnosed by the first X-ray. After that, X-ray will not be helpful because it was infected more and more to the lungs. So that lungs opacity was needed for that. So how they applied? They applied MRI or other scan. So one to other scan when when doctor will give the opinion, once the need will be there. That means sometime X-ray will not be able to provide the condition of lungs. So we will go for MRI, CT scan. So like that, in this case, the research would be this one. How deep learning application will be applied? We have to segment the brain. You can see here, this is the complete brain. These are the condition of internal structure of the brain. So we have to apply segmentation. We have to register all these points, all these pixel value. Then these pixels are suppose if this area, there would be some tumor would be generated. Okay, so in this image will not be there, but generated this by the segmentation we will be able to analyze. How it will be analyzed? By the segmentation. So we'll say that is the segmentation approach, registration, brain MRI registration, computer aided diagnosis. That means AD or MCI diagnosis will come under this, or skin cancer detection that will be applied, or image synthesis. So these are the analysis area will be there in medical imaging, and deep learning how it would be helpful. By the registration, we can register the pixel value. We can enter the value by the image processing, and based on that, we can help to brain MRI registration. Similarly, this hippocampus segmentation will be helpful in terms of brain. Computer diagnosis will be helpful in cancer detection, and image synthesis will be helpful for estimating the computer tomo from MRI images. That is what are the brain part will be there, skull part will be there. If you see the advantage, disadvantage, we can say completely deep learning is the high data can be handled, big data can be handled, and the cost effective. So if you see high performance on multiple domain problems, that means there are multiple problems are there, speech, language, vision, game, and it's require large amount of data. The major problem of deep learning is if you have 1 lakh data, if you have 2 lakh data. So it's very easy nowadays. If you go to the hospital like Yashoda Hospital in Hyderabad, if you go, so you will get around every day 100%, 100 or 150 MRI are going on. Definitely. So in a month, how much MRI would be available? In a year, how much MRI would be available? And that will be stored inside the computer. What they will do, they will just flush the images only. So if someone wants that images, what they have to do, they have to collect, they should have memory. So that is the problem. What is the drawback for this system? Data is huge. That's why I said huge amount of everyday data is increasing. Like in your mobile phone, if you see when you purchase your mobile phone, the size of the memory to 56 GB, how much you are utilized initially? 1 GB, 2 GB. Now how much is utilized? More than 100 GB. Why? Because everyday images are increasing and the process are decreasing. That's the reason why mobile phones are degrading day by day. Why systems are degrading? The burden of data. So we have to free the images, you have to remove the images, you have to free the memory. Similarly, here also the performance will be degraded because of this data. Require huge amount of data and rectify the need for feature engineering. No strong theoretical foundation is available. In that case, also we cannot solve the problem. Similarly, can be adopted a new problem with a new architecture. Like that, suppose you have developed one model and you have tested 2000 images 5 days ago. Now you got today 5000 more images. So you have 5000 new images and your algorithm achieved 99% accuracy at that time. Now, if you are using deep learning, your model is adapted. By the next data also, by the previous examples also, it will train again, it will test again, and it will adopt that feature, whatever feature was not adopted earlier from earlier training time, it will solve the problem. That means any time if you are having, like can be adapted for new problem. If any new, suppose you have trained your model with MRI images, now you receive CT scan images, or you receive other kind of modality images. So that same model, we have to train and test whether it will provide the result or not. Definitely to provide 95% accuracy. then you can modify your feature. Some more feature will be added, some extra feature will be added. You can get the. That means any problem can be adapted with a new problem solver. That like vision, time series language, using convolution neural network, recurrent neural network, or long short term memory. So this is the our computer vision system is there. How our system is like how human vision systems are working. We know very well. We have human, we have vision, we have brain. Brain and vision, these components are working human vision system. So we are looking something and our brain are learning by looking something and brain are learning by looking something and finally once new thing will come in front of us, we will recognize. Why? Because our brain has trained with known example. Now if unknown example may come, our brain has to recognize with the knowledge of previous example, with the knowledge of previous data. Like example is I learned about red apple only. But suppose in front of us green apple may come or blue apple may come. We will be able to recognize or not because we know the texture of apple instead of color. We know the texture of apple because texture of every apple would be same. So like if color of the ball will change, we will not be able to recognize by the brain. Definitely because we know the texture of the ball, not to color. Color is not a prominent feature for us. Our prominent feature is texture. So in imaging, like same imaging also will have a low level feature, will have medium level feature, will have high level feature. So low level feature only colors. But high level feature means texture, pattern. So the edges will come under low level feature only. So human are trained with high level features. That's why human can recognize any kind of color ball, any kind of color of any like any banana or any kind of thing, because in the world any variety would be there. You don't know which variety would be available, but brain can handle. Sometime unknown thing cannot be handled if brain has not trained with that. That is called failure of the system. That is called. Similarly, here also some kind of images will not be determined, will not be recognized by the system itself. So we'll say this is the computer vision system. Computer vision system require image processing. Image will be acquired through the camera, through the sensor. That is called image acquisition. Then process the image. Why? Suppose you are taking the picture of me and your image has blurred, or your image has like some light was not proper. This serial light is not proper. If you take picture, illumination without absence of illumination, picture will not come proper. What you have to do? You have to improve the image. That is called image enhancement. You have to improve the quality of the image. Then image will be suitable for further application. So we can say here, image processing is our requirement. Process the image by means of computer. That is called image processing. In terms of image enhancement, in terms of image restoration, then segmentation. Segmentation means I want to divide the image into different parts. Okay, suppose I have this is suppose my region of interest and I have coins. Okay, these are the coins for me. I want to count the coins. Okay, machine has to count the coins. What you have to do? You have to segment 1, 2, 3, 4, 5, 6. So that is called partition the image. That approach is called image segmentation. So we are doing the segmentation, and after that segmentation means estimate the feature. As I said, I have this ball and I have this apple. I have to recognize both. Both color are red. So my first feature is red color. What should I do now? Red color is common thing for me. Now I have to teach to the machine. I have to teach my child. This is apple, this is ball. How to teach to my child? See the texture of the ball, see the texture of the apple and say this is apple and this is the ball. Color will not be responsible to decide that object is object. So means that we have to apply the feature estimation. Feature would be geometrical features, topological feature, texture, pattern. So pattern recognition would be there, pattern classification would be there. Then all this will be combined with respect to computer plus software plus knowledge database. Knowledge database means Without knowing of that data, knowledge, you will not be expert. Like I said, ultrasound, I am doing ultrasound. If suppose I am a technician ultrasound, if I don't know ultrasound, how to start, how to take the electrode, how to apply the electrode, how to apply the material, and how to get the screen. So I am not suitable for that. That means I should have knowledge database. So without knowledge database, the system will not work. Like without knowledge of math, physics and chemistry, we cannot be an engineer. We will not be an engineer. Why? Because we don't know physics, chemistry, math. If we know only biology, then biology means we cannot, without biology, we cannot be a doctor. So like expertise is necessary, knowledge database is necessary. So here we are developing a software and with the help of computers. So we should have equation system, we should have image processing based system, we should have segmentation based system, then feature estimation and feature data analytics. That is the role we have to do. Now engineers has to do data analytics. How industries are working, what they are doing, they're collecting data from medical practitioners and analyzing the data and providing the best suitable software to them, best suitable code to them, then recognition, classification, and interface. Suppose you want to buy one device like biometric device for your institute. So what is the requirement for biometric? You have to enter the biometric for your whatever the your people are there. Okay, so they will enter their biometric. Okay, first they will enter their test biometric. After that, next day onwards, they will punch the biometric and they will test. So your attendance will take place. So whatever the biometric designed by the company, what they have given to you on hardware and software. And as well as they did not give your own database. What they ask, you create your own database and ask to your employee, just give the database and after that make with database. Then attendance system are once. So that's a simple case. If you are buying any hardware, with the hardware, there the software would be there, algorithm would be there, and based on the algorithm, you are getting result. But sometimes if you face the problem like you are punching your fingerprint, not detected. Very possible or not. Sometimes it may happen. So this is the failure. This is a failure of system. So definitely you have purchased the biometric, the accuracy of the biometric was 98%. So it does not mean some people they will not detect. Definitely some situation may be there, like if you buy the face recognition system, face attendance system. So what you will do, you will tell your face. Now once you have taken the face, at the time my beard was more and more, I have given my face. After that I removed my beard and I cut my hair and all. Somehow I change my geometry of the face. Then definitely machine will disturb or not. So that is the occlusion condition would be there. So similarly, if you have given whatever the medical data, day one you have given data. Why you are observing the every time data, like suppose someone have experienced accident and X-ray taken by first day. Then X-ray will taken by second day. After that operation completed. Then after 30 days, there will plaster. After 30 days, plaster will open. What they will do, they will again go for the X-ray. They will see what is the situation. After 2 months also they will ask, because after healing will take place. Okay. So healing will change in the X-ray or not. So that's the more important for us, how the image will be recognized at every stage. Okay, so this system will work. So deep learning is one of the tool requirement for us, how to develop the tool, how to develop the software with the help of hardware. So this is the level of process. So in image processing, you have studied or you know very well image processing is process the image by means of computer. So first step is image acquisition. Image acquisition is your camera, your sensors. Now you are looking the image or not. So this is the sensor for us. So image processing will be taken care by image softwares. Okay. So under that knowledge base is necessary or not. How the machine will understand it is image enhancement or it is image segmentation or it is image visualization. So first step acquisition. That means hardware will give the image to the computer. After the computer pre-processing. Then segmentation, partition the image. After partition, represent the image. That means every value will be represented. Suppose you have this kind of thing. This is kind of skeleton. So skeleton will tell us this is feature, this is feature, this is feature, this is feature. So you are representing this would be a one shape. Shape analysis, will be taken care by the image representation and description. It will become a feature, and this feature will feed to the recognition part or interpretation part. Interpretation means decision making will take place, and all this will be handled by knowledge. Knowledge must be necessary. So we started low level processing, intermediate level processing, high level processing. This would be there under image processing. Now, level of processing, standard procedure applied to the image improvement. Quality of image will improve. Procedure are required, have no intelligent capability. It does not require any intelligent capability because it's a low level process. Process the image. Suppose this area I have taken the picture, no light is available. I'll change the light. How I'll change the light? I'll make picture would be more and more brighter, more and more darker. So brightness and contrast, these two knob with you is there. In your TV, you are changing brightness, you are changing contrast. By that way, you are able to improve the quality of the image. That is called object. Now, if your image has degraded, suppose you have taken image 10 years ago. Now you want to improve by the prior knowledge. That is called image restoration. Restoration means you have recovered your degraded image. That approach comes under the subjective process. So objective and subjective two approaches are there to change the intensity inside the image, to the proper intensity inside the image, and intermediate level procedure extract characteristics of the component image. Like I said, coins, or I may say two objects are playing on the ground. We have to extract the particular object only. We have to extract the only two players only. We have to remove background. We need to concern only two objects. So likewise, object detection will take place. Like you will see you are going in some shopping mall. Shopping mall, you have seen various cameras are there. So under that, what they are looking, they are only capturing the users who are coming. Customers are coming. So what customer they having? Their whatever the using material they are keeping and all, how they are keeping like that. So everything will be detected. So sensor will active once object will come. That is called motion sensor. Like lights are there, once will go, light will on, once will not go, light will not. So that is called motion sensor. So motion sensor means your camera will active when you will be there in front of that rack. And you are keeping something, camera will actively measure to you what your activity. If your unavoidable activity would be there or some suspicious activity would be there, suppose someone is keeping inside the bag and all. So that will be sent and put down. That is the mechanism would be there. Here, what you have to do, you have to first partition the object or with their whatever the packets you are there using, they have to identify. Then they will do activity. That means that is an intermediate. The object, divide the picture into different parts to get the characteristic of the image. So some intelligent capabilities are required. Finally, higher processing recognition. That means it will recognize who are you, your name. So like suppose you have entered your data in terms of some industry and they have given to you the one pass, one ID card. Once you just press the ID card, your database will show you this is the person who will be there, attendance taken care. So that is the recognition. So it will be required high intelligent capability. That means it must be recognized like your passport. Your passport is high intelligent capability would be required because you are going to the other country. They are measuring your biometric. That they are having your iris sometime. Many things are so many biometrics are there. So all this would be their level of process. Now, how architecture will be helpful in this case? That there are many architecture has been developed for implementation. So we'll say acquisition, digitization, calibration, registration, optimization, transformation, filtering. Now, this is the shading, display, visualization. This is called feature extraction. What is the topic we have? We want to analyze the images. So first case is visualize. Image acquisition will be visualize. Acquire the image by this process. This process display. Display is the device where you produce the illumination with the text. These are the text. Now this is the process where what exactly process will apply. When we want to recognize object, what is the first step would be there? Suppose I want to recognize someone. He is my scholar. I know his name. How I recognize this feature? I'll extend his feature. My eye will extend his feature. Okay. After that, I classify by my brain. Will feed to the feature to the brain, and brain will be detected. He is that person. He is my scholar. So that approach is called analyzing. So in analyzing, we'll have the feature extraction, we'll have the segmentation, we'll have the classification, then interpretation and measurement is our necessity. Okay, like example of we have taken chest X-ray images. In chest X-ray images, we have collected multiple images, healthy or non-healthy patient. After that, what we will do? First, we'll analyze first healthy image. We'll see whether the pneumonia is there or not. We'll extract the feature of pneumonia. If not there, we'll say this image is healthy. Similarly, we'll see one more image that will have the pneumonia. Some different type of pneumonia will be there, like bacterial pneumonia will be. We'll see the some lung opacity. Under that, there will be some changes are there. I will say, okay, this condition is not healthy condition. This is the pneumonia condition. After that, I'll see feature of the labor pneumonia or feature of the bacterial pneumonia. Then I'll say, okay, this person having this pneumonia. Then I will recognize. So finally, classifier what exactly will do with the best feature, best segmentation, it will be recognized or measure the or analyze the images. Will have the pneumonia or will not have it. Similarly, third case, we'll see here filtering. Filtering means what exactly we are applying. We are having the compression. We are having the archiving, we are having the retrieval, or we are having the communication. That means transmitting the data and manage the complete system. That approach comes under the management. Similarly, image formation. So our first step is what? Image formation. How image will be collected. So that is called image acquisition. You can say image acquisition. In your mobile phone, you are using mobile phone. You are capturing the images. So that images are digital or analog? Digital. So your mobile phone itself will have the digitizer. Simply quantitation and coding. That already would be there. So we can say it includes steps from capturing the image, forming the digital image in terms of matrix data. So image acquisition and image digitization will be the process under the formation. Similarly, under the image acquisition, we have imaging database. We have imaging devices. Example, we want to collect CT scan, X-ray, MRI. So physical phenomena would be converted into a electrical with digital phenomena. So electrical will be given by sensor. Sensors are available, different sensors like CT scan, like MRI. So we are providing various radiation. CT scan, MRI is the radiation. By the radiation, we are collecting the radiation and mapping on the that is on the film. So by that way, we are getting the raw data. After that, this would be the device. Like you are measuring the temperature by a thermal sensor. Thermal signals are sending and temperature body will be measured. That is the nowadays very common. Okay, but this was not common before corona, before COVID. But after COVID, it became common. Like oximeter also will be new thing, but it was not common before that. No necessity was there, but nowadays necessity came. So because COVID is one of the disease nowadays, still it is there. So it will be required to measure. So all these instruments are very commonly available in the hospital. So finally, digitization also one of the process will be done by system itself. So if you are using CT scan, if you have seen CT scan machine, if you have seen MRI scan machine, who is doing? Technician is doing. How he is doing? He is asking to the patient, go in the machine, and what he is doing? He is applying the operation by the computer. And where he is printing the images? Through computer. So collection will taken care by computer. Computer will store only numbers, digits. That means it will require digitization. So finally, radiation will be applied to the patient. Collection will be taken care by collector, and collector will be again a physical phenomena to sensor. That means electrical phenomena. Electrical phenomena will be converted into digital phenomena by digitizer. So digital process will be taken care by sampling quantitation and sampling rate will be determined. All these are the strategy we are using. So now example, by the sampling we are changing the size. Now quantitation we are changing the gray level. That is how many pixels we are using. So if you are using more pixel to represent the image, more quality, more data storage. So this is the only impact of the resolution. So resolution impact because of sampling will change. If you are having high sampling, you have quality resolution. Size of the image would be like that. Size of the image size will be more resolution will be there. So now we'll see bit. So if you are using 2 bit, now which image is better? This one or this one? This one better or this one better? 6 bit better. So if you are using more bit, suppose I have taken one image from my photograph, my passport photograph, one is a 1 MB and one is 100 KB. Which one will be more better? 1 MB, because more data will be available. That means more zooming will be applied, more exposure would be there. So that is the two case will be there. If you are applying sampling, you can see the resolution condition. If you are applying quantitation, you can see the gray level condition. Similarly, pre-process. Pre-processing, if you are a medical imaging, uh, if you are a user of medical imaging application, so you know pre-processing exactly what exactly will be. Your data will be raw, that is not suitable for machine. Like you are buying from the market some green vegetables. So are you using directly? You are filtering through the water, you are cleaning and then you are using. Because in that case, dust will be there. Okay, material would be there. Likewise, whatever the image you have collected through the sensor is the raw, not suitable. After your CT scan will over what that technician will do. He will allow you to go 4-5 hours. Come after 4-5 hours. I give the report after 4-5 hours. What he is doing? He is doing setting. He is doing pre-processing. He finally then he will send to the machine learning software or just decision making software. Then he is giving report. Then he is printing. So like here also raw data will be given in pre-processing. Pre-processing will be clean the data, enhance the data, make the data suitable for further application. So that is our requirement: noise suppression, contrast enhancement, intensity equalization, contrast improvement. All this will be taken care at this level. Now outlier elimination, bias compensation, many things, filtering and all. Now pre-processing, we have multiple algorithms. We are using enhancement, we are using filtering. Okay, we can use low pass filtering, high pass, band reject. Filtering technique will be applied. Similarly, we are applying registration approach, collecting the data, calibration, calibrating the data. Finally, transform the data. Like transform time domain data into frequency domain data. We can apply Fourier transform. We can apply cosine transform. We can apply multiple transforms. So transformation will be applied to collect the data in different domains, so that image will be suitable in particular domain, and we can take more best decision according to that domain only. So similarly, enhancement. So enhancement, various approaches are there. Like enhancement can be applied directly spatial. What do you mean by spatial? Spatial means directly play with pixel, play with your number. But in terms of frequency domain, what you have to do? Yes. So you can apply Fourier transform. You just apply the f of x. Your information is you will take Fourier transform f of x. So it will convert f of omega. So that means you have prism. And by the prism, you are passing 3 different colors, RGB. But after the final prism output, how many colors will be there? 7 colors. So 7 color, you have exposed your color more extensively. So according to that, you can recognize more information. So if you have more depth in your signal, you can recognize more information. And more information means that will give the knowledge of to understand that particular domain. So here we are using time spatial domain method, directly play with pixel, or you can apply frequency domain method. So objective of enhancement is to process the image and result is more suitable form. That means image would be image only, but Now image as enhanced image, improve image. You can say brighter image or contrast, more contrast. So image would be more and more brighter, image would be more and more darker. So that is the quality image. So image enhancement technique is divided into two parts. One is biaxial domain based method or frequency domain. So we have best method out of all methods, histogram equalization. Histogram equalization means pixels are distributed unequally. But what we will do by taking off PDF, by taking off PDF, probability density function, cumulative density function, we will map the new value. New value means previously 0 pixels was arrived 10 times. But pixel number 1 was arrived 5 times. That means all pixels are narrow. So suppose if you have the plane like that, suppose your all pixels are here only. It's a low contrast image. If your all pixel would be here only, it's a high contrast, brighter image. So it's a dark image, it's a bright image. And sometimes it's a center only. So it's a poor contrast. But all these value, suppose you will stretch it. That means you will distribute like that. That is called equalized. So histogram has equalized. So image was not properly looking, now it will look proper. That is the reason we are using this approach, histogram equalization, image subtraction, point processing, and frequency domain method. That means you have image, you will take Fourier transform image, so you will get the value, low pass detail, high pass detail. That means centrally value will be concentrated, will show your high edge detail. So in image we have two kind of detail. One is low pass detail, one is high pass detail. Edges comes high pass detail. And image if suffered by the look, that means noise. Noise will affect to high pass detail, edges. So if you apply low pass filter, what will happen? High pass detail will remove. Only low pass detail would be there. That means edges will be removed. Image will become blur. Image will become smoother. That is called image smoothing. But if you apply high pass filter, you can recover edges, high pass detail, but noise will be affected to low high pass only. So noise could be there. So low pass and high pass, that means image sharpening is called high pass. Image smoothing is called low pass. So that approach we are applying in terms of filtering. In terms of filtering. But enhancement, that would be suitable for okay. So according to that, this is the approach. So suppose you have vertical image. Now see this image. Brighter parts are looking or not. See this portion was not suitable. Skeleton was not able to visualize. After enhancement, this would be there. Now see this is the area is cancelled. This would not be reflected in this case. Now we have converted into brightness. So we can recognize black area. This black area is cancelled. So image enhancement will improve the quality of the image. Image was not observed properly because proper illumination was not considered by the technician or by user. By taking the image, he was not aware here light is not good, here illumination was not to be captured. But it is your hand, you can improve the quality by applying a histogram equivalent. You can equalize the value, you can spread the value, and you can get it image will be suitable. Image will be suitable. Now this area is cancerous, we can become that. Similarly, filtering. So we have the filtering, average filtering, median filtering. So maps operation we are doing. So image processing is nothing maps operation. Image is nothing matrix. Image is nothing matrix, and we can apply maps on that. We can take median. So median filtering will remove the noise. Which noise? Short and simple noise. We have average filter, low pass filter. We can say average filter is low pass. So average filter will smoothen the image. And max filter, mean filter. Suppose you want to apply median filter. Median filter will take 9 values. 1, 2, 3, 4, 5, 6, 7, 8.
Now center value is 1, 2, 3, 4, 5 is center value. So take the center value and arrange the value in ascending order. 1, 2, 3, 4, 5, 6. What is center value now? 4. So 4 will be replaced by center value. So it will become a median filter. Take the mean of that value, mean filter. Take the maximum of that value, maximum filter. Average filter means take the 1 by 9, 1, 1, 1. This is the weight, this is the mass, and this mass will be applied on the image. Where the mass will be multiplied or convert, that area noise will be eliminated. But image will become smoother. Smoother means blur. But because of blurring, what impact will come? Image noise will be removed. Noise will be removed. After that, we utilize this image, apply the high pass filtering, we can recover it. This is the smoothing. See the smoothing? Image has blurred. It was the properly looking. After that, this is the so the aim of smoothing is that in effect of the camera noise, pixel noise or missing pixel will be removed. So two methods: image processing, neighborhood averaging, or edge preserving. We can preserve the edges also. We can apply registration. We can apply the CT scan in multi projection. So medical image registration for data field patients taken at different point of view. That means the brain, whatever the physical condition would be there, what exactly technician will do, he will ask you to keep your hand like that, like that. Every area the image will be captured. That means that is called projection slide. That will come under the slide. So brain will become a slide. Like you have a one apple. You are cutting like a slide. So brain will cut like a slide. So every projection will take place and that can be recognized. Suppose the brain having the cancer of this area or this area, this area. So it will not come first slide. It may come third slide, it may come fourth slide. That's why image condition is very important area in research. That's the case would be there. Medical image registration of the data, same patient taken the different point in time, such as change detection or tumor monitoring. So tumor monitoring will be taken care by the registrar. Calibration of images have been acquired with same modeling. This is the thing. See, this is the condition. Multi-model. Same brain, these are the ways compared. The image has been captured with different modeling. Now transform it. As I said, transformation means can be applied a arithmetic operation on image or complex mathematical operation which convert image to one representation to another representation. That means I can say you can transform the image in time domain to frequency domain. You can see DFT, discrete Fourier transform, DCT, discrete cosine transform, wavelet transform. So these two last transform is very helpful to extract the feature. We are not, everyone has seen the various paper, we are applying wavelet transform. Wavelet also various filters are there, various types are there. Double cheat is there, discrete Mayer is there, or R wavelet is there. So various versions are available in this. Cosine transform is the Fourier transform, but Fourier transform is a complex transform. And cosine transform is non-complex. So only cosine value will be considered. Similarly, we'll apply, we'll get. So you have seen this is the image. This is the histogram. This is the image, this is the histogram. So these are the, and this is the final representation of feature. Now analysis. So what we are doing analysis? Feature extraction, segmentation, classification. Images are available. High level processing is applied. That means image representation, description, and recognition. That is the last part we have seen in the diagram. You can recognize feature extraction, segmentation, classification. This feature will be in which feature extraction and classification. There is the one more approach we are applying, feature selection. Why it is necessary? Because sometimes there are multiple features will be detected, and some features are redundant, not necessary to apply, and it will just make the algorithm complex. So what we will do, we will not consider. We will select specific principal features like dimension reduction will take place. So we have one method PCA, principal component analysis. If you are, that method is reducing the feature. So you can see here segmentation. So segmentation is process for partition the image into different meaningful segments. We have different meaningful segments by that way. So this is the whole brain segmentation. This is the different and this is the retina segmentation. So if you have seen eye has been captured by which imaging? Fundus imaging. So fundus imaging is required to understand, to know about glaucoma, to know about diabetic retinopathy. So that is another area. And fundus will be captured by different imaging. So we are capturing the images by different imaging technique. So these are the medical imaging segments correspond to different tissues. Tissues have different classes, organs or pathology or other biological relevant. Now segmentation will be done by different modalities. Now it will be detected under the vessel and liver, cardiac imaging or brain. So these are the different of pixel-based method. You can apply thresholding, you can apply age-based segmentation, you can apply region-based segmentation. So under these various algorithms are one. Similarly, these are the methods segmentation. Air, fat, water, and bone will be segmented. Like that, the original image, initial segmentation, final segment. Now, feature extraction. So, feature extraction is very important part. Is defined first stage, intermediate stage, high level image analysis, followed by segmentation versus classification. So, first shape-based feature will be detected or size-based feature. So, these are the shape-based features. That is called whatever the circularity will be there, roughness will be there, elevation will be there, compactness will be there, eccentricity will be there, all comes under shape based. Under the size based area, convex perimeter, diameter, major axis, minor axis, color based feature, color histogram, color movement. And local feature, these are the methods will be there. If you heard many feature extraction technique like scale invariant feature transform, SIFT, speeded up robust features, SURF. HOG, histogram of gradient, and many are there, LBP. Nowadays, ready-made feature extraction techniques are available. You can use directly. So this is called local description. So feature extraction will be categorized in this group. So it's followed by segmentation and classification. Feature extraction, various other features like intensity based, mean, median, standard deviation, texture based, Gabor filter, Markov random field, LBB feature, or Hurley features, age based, age detection, number of ages, age intensity, and finally frequency based feature. So I said Fourier transform, discrete cosine transform, wavelet transform. So it may give us this kind of feature. It will be at frequency too. Now examples. We can get this image, various images. Now see this image. Yes, see this image. This skull will be there. This is the age detection. This image, we are giving different segmentation. This image, this is the edges. By age detection, we got this bone structure. Classification. Classification will tell us how machine learning, how you will make machine to understand, how you make machine to take the decision by the various machine learning based techniques. So under that, we have two kinds of machine learning technique. One is supervised, another one is supervised. So how you have learned alphabet? By your teacher? By book? How you learned about alphabet? By your teacher taught you and by the book was there. Book means label was there. How your teacher taught you, he know A is A, B is B, but he know the book. And sometimes you read the book, A is A, B is A, B, C is a C, D is a D. That means label. So data would be available with label that will be designed by supervisor. Supervisor, teacher will teach some content and machine will learn. That area is called supervisor. But teacher is not available. Some subject you are studying by yourself. No teacher taught, no book is available. You have collected information and you have analyzed, you have finalized, you have given exam, you got 90%. You got 80%. You got 100%. That means that is called unsupervised learning. No teacher. So how will solve that unsupervised learning? By clustering. So we will cluster only where the information are grouping, will make it. Like you found this information relevant, group. Not relevant, remove. Grouping, relevant, grouping. So group and ungroup, by that way you have clustered the data. And your brain has trained by yourself, okay, this information is correct, this is wrong. But you cannot judge because you don't have output. You don't have output. You cannot check the error. Suppose yesterday I learned A, I verified by A by book, then I said 100. No error. But A I learned today by B. So error. So A minus B, that means some error would be there. So I cannot say 0 has not achieved. So I have labeled data, so I will teach the machine. The machine will learn by the example, that example would have label. So under the machine learning, we'll see, and feature will be analyzed, feature will be accepted and feed to the classifier. Classifier will tell the decision this image is related to pneumonia, is not healthy. This image related to not pneumonia, healthy image. So we are going to classify. So apple versus ball. First stage, machine has learned colors, not suitable. Then second stage, machine has learned texture. Then we have shown to the machine what is this. Machine will tell ball. Second stage will show to the machine apple, any other color. Machine will tell this is apple. Multiple time will show apple ball, apple ball. Finally, we will bring some difficult test. We will bring some difficult balls and difficult apples. Will not known about the machine. Will show the machine. Machine will say it is apple, it is ball. Then that is called testing. So testing time, no label is required. Testing time, no label is required. Machine has to test, like you have taught your student 5 minutes and you ask the question. That question was not taught in the class. Then you will measure how much score they received. Some student got 85% marks, some student scored 5 marks also, some scored 98% marks. That means how much they learned, they applied it. Okay, so that is the machine learning we are doing. So in our case, yes. So classification is our requirement. So we have multiple classifier. Classifier is statistical classifier. Statistical classifier means we have seen various statistical things, mean, variance, standard deviation. These features are responsible to analyze or to identify whatever the input you have given as an image and will give the output. That means suppose image you have given brain tumor, you want to detect brain tumor. If output will be brain tumor will be detected, that means your output has reached. So classification completed. So statistically you have calculated mean and variance, and without brain cancer, mean variance was different. With the brain having cancer, mean and variance will differ. This image is cancerous. This image having cancer because mean and variance are different from their original to deviated value. So deviated value will tell us, that is called statistical classifier or machine learning, which make the decision about the class or category of any input will be given based on their statistical property of the data. And this classifier learn from the data and often training, label examples and make the prediction or classification of unseen data. Correct? You are asking your student unseen questions only. They don't know which question will be there in exam. You made question paper and you have asked them, they answer. They did not answer, they may answer, both condition would be there. So we have common example, Bayesian classifier. You know maths. You studied Bayesian theorem, Bayes theorem. Bayes theorem is a probability theorem. Under that probability means today rain will come. What is the dependency? Rain will come this month, December month. July rain will come. What is the probability? More probability. Because July is the month of rain in India. Now, suppose there is another prediction. Rainfall will come or some other kind of
equation will come. So probability will tell us with the conditional probability. That can be solved by Bayesian theorem. So based on the Bayesian theorem, we have designed Bayesian classifier. Another classifier is support vector machine classifier. What do you mean by support vector machine classifier? We will classify 2 value or 3 value or 4 value. That means multi-class problem. So we have one class problem. I have, this is condition, I have this condition and I have various value triangle. I want to separate them. I want to classify them. What should I do? I'll make a boundary here. And this is my hyperplane. And this value and this value will be decision to hyperplane. This is condition H1 and H2. Based on the condition, I'll send the circle here. Based on the condition, I'll send the triangle here. So finally, I have seen this area or triangle, this area or circle or triangle. I classify the 2 class problem, binary problem, 0 and 1. So by this way, I have separated this. What do you mean by this value is called support vector? It is separated by decision boundary. Now, suppose I have one more value like a rectangle. So I will draw one more line. I'll separate them. So I will make them to go above the decision boundary. Based on the algorithm, based on the kernel, based on the weight. So that approach is called support vector machine. We have random forest, we have nearest neighbor. Nearest neighbor means suppose you have taken this area. And he will what exactly will see? It will calculate the, he will see what is the nearest neighbor. Each one is, so I have this data, I have this data. So what I will do, I'll start, I'll calculate the mean and I'll merge it. I'll merge it. So this area will be merged, this area will not merge because it's away from that. So mean will be more, distance will be more. So I'll calculate the distance, based on the distance, I will merge them. So by that way, I am classifying, this area will be classified, that area will be classified. So likewise, we have multiple methods, LDA or many other methods are there, like computational intelligence based method, like ANN. ANN, so you know ANN, artificial neural network. Everybody knew about our biological neural system. We have biological neural system. Under that biological neuron, we have neurons. We have neurons and neurons are interconnected. And neurons are exchanging the information. So we are thinking that means some weight will be there on that time, on that neuron. Okay, so neuron having the weight. So what same way we are creating different neurons artificially and making them like a biological neuron. So what is the structure of biological neural system will be there? Neuron, neuron, neuron. And they are connecting each other. So each neuron is called processing unit. And each neuron means one neuron will have one value A and will have weight AW. Plus another neuron will have the value B, then multiply W2. Then another neuron C will have the value and multiply by weight 3. Summation of all 3 values will be a output. But this output is a linear output. So what exactly we will threshold the output, will filter the output by